is smaller, lighter, and smarter. Whole technology is running behind smaller, lighter, and smaller. So tomorrow the day will come when the computer size is drastically reduced. Each component of the computer, say microprocessor or logic circuit or whatever may be, you know much better than me, they will become not more than few atoms. And Feynman told there is enough room at the bottom. So that whole library can be stored in a tip of a tip, one quantum dot. So gradually you should prepare that your computer will be smaller beyond expectation. When the computer will become beyond expectation, each component will come under not classical mechanics. They will come under quantum mechanics. That is why the thinking size of computer, each component will govern by not classical law. Your electron, your proton, your neutron, your atom is not governed by classical law. They are governed by quantum law. So that fusing quantum mechanics to quantum computation is called the quantum computation. Now next slide. Yeah, next slide. Yeah, this is over. Next. Our normal perception of the world, I have already told, I don't depend upon this slide. Slide is for you. That is pedagogical teaching. Our perception of the world is classical. We are very much comfortable with Newton's law, Kepler's law. Example, apple falling, body flowing, like that. Many examples, countless examples you will come across. Besides, what is the beauty of classical mechanics? The beauty of classical mechanics is, besides the determination of a position, momentum, trajectory, everything, where the particle is, what is its velocity, what is its momentum, what is its trajectory. If you throw a ball, then if you know the projectile, you might be knowing the projectile in plus 2 level. Through the projectile, you will know where the ball will hit, how high it will go, what is the range, what is the velocity. Everything you can determine precisely with accuracy. All of you knowing Heisenberg uncertainty relation. It is impossible to measure both position and momentum simultaneously with accuracy. So classical is quantum concept. Uncertainty, Heisenberg uncertainty principle is the quantum concept. So classically we are very comfortable. A central concept of classical dynamics is predictability. You see it, you believe it, you measure it, you calculate it, you estimate it, you tell. Sir, this is the position, this is the momentum, this is the energy, this is the range, this is the height, this is the velocity. Any numerical will come under the classical mechanics. You can solve it. Next slide. The classical way of looking the thing, the world is considered to be made of observable object, field, fluid, like that. There may be 3 states: solid state, liquid state. This is the universe. You see, generally some concept will come in spite of so much comfortable with the classical mechanics, Newtonian mechanics, or Kepler's law. Why you go for that quantum mechanics? Is it for change to change sake? Change is the only constant of life. Every day you want change. But sometimes change is made with intention, sometimes change is made just to change for change. Remember, my friends, transition from classical to quantum is not change for change. There are some experiments which are not classically explained. That is what is called the limitation of classical mechanics, inadequacies of classical mechanics. What are the experiments where classical mechanics is a brand failure? We will discuss. And in order to cope with this, we have to necessarily go for another mechanics that is called quantum mechanics. And basically, you understand quantum for micro world, classical for macro world. Next. Here, quantum mechanics is not possible because outcome can be predicted. In quantum mechanics, determinism, certainty, trajectory, is not possible. Everything is in probability. Remember, position, probable. Everything, you think of I am here. Classically, what do you mean? The probability that Professor Panigre is here is 10%. What is my probability outside the room? 0. There is no other way. Either 0 or 1. If I am here, I am not elsewhere. I am not elsewhere. But tomorrow, if the God will make me a electron Panigre, suppose my size is drastically reduced to the size of electron, you cannot say that 10% probability that I am here. It may go 99.9. It may be possible. But there is a finite probability that I will be outside. There is a finite probability that I will be outside the classroom, outside the campus, outside the Raurkela, outside the Ganjam, outside the Odisha, outside the India, or something like that. There is finite probability. So mechanics is fully probable. However, the expectation value, the probability may be somewhere higher, maybe somewhere lower, but it's unpredictable. Really, next. You see, in the cognition of the brain, when you think of a classical world, first you see the phenomenon, then observe it, then image, then formula, then concept, then experiment. This is classical domain. Brain will automatically work. When you see a pen, the brain will automatically work in this order, in this order. But look, when you go to the quantum chain, your cognition, you may not experience, but the first part you experience. The second part, the order is not same. Manifestation of phenomena, observation, formula, concept, theory, experiment, image. The order is not same. Understanding the order at this stage is not possible. And when the talk is over, you can understand. When you go to the same slide after the talk, you can understand what is what. Please have patience. Is not that slide number 1 will be 10% understand, then you go to the slide number 11. Then you will go to the slide number 40, slide number 11 will be clear. Okay, next. So now, just like I told, why you go for quantum mechanics? Is it for change sake, or is there any? Yes, there is some defect. There is some inadequacy. There is some limitation of the class. What are the experiments? The very well-known experiment is black body radiation, what you call ultraviolet catastrophe, and the other one is your photoelectric effect. I believe if I am not going to teach you what black body radiation, it will take you 3 classes. I will not teach you what is photoelectric effect, it will take 2 classes. But my education only 1 hour, but actually the management telling that likelihood that effect continue afternoon also. So I am little comfortable. My slide is equivalent to not 3 to 4 classes. So I will only briefly highlight you where the classical mechanics is failure in black body radiation and what is the dose of quantum dose. I will briefly tell you where classical mechanics is failure in photoelectric effect and what is the quantum dose. Then, in black body radiation, but little physics is definitely necessary. If you don't know what is black body, how can I tell you black body radiation? A black body is a body which observes all the radiations that falling on it, and as I say in physics, good observer is good emitter. It also emits. Remember, a black body is assumed to be collection of large number of harmonic oscillators. It may not be black also. Not necessarily color will be black. Any body, but necessarily black has more observing power. But it is not that perfect black body is not possible. No body is perfectly black. Nature is not given as, perfectness in anywhere is not possible. Perfectness is mathematical concept, word of reality. Nowhere there is perfect. Perfect black, perfect intelligent, perfect good. Perfect is a concept. It is word of reality. It is a mathematical model. So what you do is that this cavity you have to design as a representative of the black body. Its color is black. Naturally, the color is black. So when radiation falls on it, by virtue of multiple reflection between the walls, all the radiations are absorbed. That is why you treat it as a black body. So now to understand the energy distribution of the black body, 2 to 3 classical mechanics physicists, they have given a formula. Experimentally observed radiation do not fit with their formula. That is the defect. What are the formula they have given? Next slide. You see, Rayleigh and Jean is a classical model. Would you mind if I tell what is the basic physics knowledge? +2 or +3 or what? In general, I should accept +2 level. Of course. Multiple reflection. When a heat radiation falls on it, in the wall, in first reflection, 50% is observed, 50% is reflected. That 50%, now suppose this is a boundary, and inside the door, hot body radiation falls on it, and it falls on the wall. And on the wall, part of the heat radiation will be observed, and rest part which is not observed, they will enter to that. From the 50%, another 50% is observed. Again, 25% is remaining. That falls in that wall. That is why it is full reflect. I will tell you, don't worry.
Hello.
Total internal reflection is different. Multiple reflection. Total internal reflection is your optical fiber or that is separate issue. That is the reflection of the. Here it is reflection of this. To light reflection. It is not. It is hot period. You are also good observer. When heat falls on it, you got hot. When you sit before a fire, you are getting hot. How heat comes? Because heat radiation falls on it. Heat radiation, heat, light, everything goes in the form of a wave. So, realizing using classical model, he has derived a formula. The energy distribution is proportional to frequency square, you see, nu square. So, when a left-hand side is proportional, all other are constant. When left-hand side is proportional to nu square, then when frequency increases, what happens? Left-hand side is, when frequency increases, left-hand side also increases. So when frequency becomes too high, then it will become infinite. So if the Rayleigh classical law is true, your intensity of radiation versus frequency, at a higher frequency, it should go to infinity. The dotted line. Rayleigh is simple formula. X is proportional to y square. If y increases to infinity, what happens to x? X will be also infinity. Similarly, suppose the intensity of radiation is proportional to nu square. On nu increasing higher, you see Rayleigh and Jean's law tells dotted line, it should go to infinity. But experimental curve show it is 0. It is a great failure. Only you understand 3 aspects. Don't go what is black body and what is like that. If classical law would have been correct, then it should follow the dotted line. It should follow the dotted line. But experimental curve is, it becomes 0. At frequency becomes higher, it is becoming 0. So in one way, you expect from the classical law, it should go infinity, but you are getting 0. Is it not a catastrophe? Big defect. It's not a defect. It is a big failure of classical. That is why it is called the catastrophe. That is called the catastrophe. So classical mechanics is failure in that. Now let us go to the next experiment. Only you tell what is the defect and what is the formula. What is the cause? Don't go into much detail because it is not the total physics we have to teach. What can is necessary for understanding quantum computation, we will fill the gap. Next, ultraviolet gap. So I have already explained. Next, photoelectric gap. Yeah, you all of you know what is photoelectric gap. There are some photosensitive surface. There is a light. When light falls on a photosensitive surface, electrons are ejected. Basic +2 physics. So ejection of electron from a certain sensitive metal surface. with the irradiation of light of suitable. You know, all metal, all light will not give you photo. That is why suitable. Why there are two suitable? The photosensitive surface should be suitable. The radiation frequency or wavelength should be suitable. So if they match it, then only there will be ejection of. So in simple language, photoelectric effect is nothing but the bombardment of light, ejection of electron. Now let us come. If you make the light source higher, and you might be knowing the threshold frequency, in photoelectric effect, it will not start from zero. Unless the frequency of the radiation is larger than threshold frequency, there is no photoelectric effect, no matter whatever may be the intensity. Look, when you increase the intensity of light, then the photocurrent should be larger. But the photocurrent doesn't depend upon the intensity. The photocurrent depends upon the frequency. And that too also, if you increase the intensity 1,000 times, photocurrent will not start from t is equal to 0. You need some threshold frequency. Unless the frequency is larger, then there is no photocurrent, no matter whatever may be the intensity. However, the intense beam, energetic beam you create, it will not give you photoelectric effect. You have to meet the requirement of the frequency. That is also classically failure. That is also classically failure. Classical mechanics cannot explain how it depends upon the frequency. Now, the third one is that ejection, if the light, now it comes that here is a particle. Introduction, one thing I forgot to tell you, introduction to quantum mechanics is the wave particle duality and quantization of energy and angular, conservation of angular and moment. There are two rules. One is the wave particle duality, second is the conservation of angular moment. Now, if the light would have been wave, photoelectric effect cannot be explained. Photoelectric effect takes the particle effect of the light. Light is a particle because how it ejects an electron unless there is light is an electron. And the photon nature, quantum nature of light is called photon. You might be knowing photon. Quantized version of energy light is called the photon. So in photoelectric, what happens? One photon falls on it and the electron is ejected. So, and photon energy depends upon the frequency, h nu. So, if you increase the frequency only, your photon will become energetic. Intensity, how many times you increase the intensity, energy has no relation. Energy is related to frequency only, h nu. You might be knowing. Energy is equal to h nu. So, in order to make a energetic photon, suppose I will give you two alternatives. Should you increase intensity? Should you increase frequency? What is your choice? Frequency. You have to increase the thing. That is why making the source more and more intense doesn't affect the photoelectric effect. That is why it is frequency. And frequency dependence energy is called E is equal to h nu, which is a quantum concept of Einstein. So classically, you cannot say why there is a threshold frequency. Why not? Immediately intensity, if you increase the intensity, it should increase. No. Now the question is that, again, if the light would have been wave, but bombardment of light and ejection of electron takes less than 10 to the power 9 seconds. So instantaneous. Can you think of how small time is that? 10 to the power minus 9 seconds. If the light would have been wave, the electron should have taken energy from the wave, then you have to think, then you have to eject. So instantaneous process, it is just an elastic collision between the photon and electron. So light is a particle. For some experiment, light is a wave, interference, diffraction, polarization. From some experiment, light is a particle, out of which you are photoelectric effect and quantum. Quantum effect is not necessary. You know, you are not going to teach entire quantum mechanics. You will teach to that quantum mechanics which will be useful to you. So light is a wave and light is a particle. Look, when you think of a light as a particle, what do you mean? It has energy, position, momentum. When you say light as a wave, what do you think of? Wavelength, frequency, amplitude. So the parameter necessary for the wave is completely different for the parameter necessary for particle. But light is both. But light is both. Is it not a paradoxical? Is it not looking something uncommon, unconventional? It looks something unconventional, but it is true. Light is a dual. Light is a dual character, wave particle duality. This is one way to the quantum mechanics. Quantum mechanics starts with this wave particle duality concept. Because now you may understand the question. If it is a particle, it is well localized. Particle mane kono? It is well localized. It has fixed energy. It has fixed momentum. So you can measure it correctly. When you talk about a wave, wave is not localized. So knowing the position of the particle is not possible. Knowing the movement, but not possible means error. There must be some error. So position, momentum, everything you cannot determine accurate when it is a wavy. When it is a another point is why you want suppose you want to find a particle, because you know quantum mechanics is mechanics of the micro world, which is the mass is 10 to the power minus electron mass is 10 to the power minus 31 kg. Think of how small is that part. So suppose you want to see the water bottle. How can you see this water bottle? Light falls on it. Light means you take a photo. It rebounds, enters to your eye, give a sensation that this is a retina. So to see the body, you have to require a probe. Probe is your light. And because the body is massive body, your photon doesn't alter its position. Now suppose you want to see the electron here. Electron mass is very light. It is 10 to the power minus 31 kg. The photon will distort. So when a probe will distort the material, observer to be observed, then determination cannot be certain. Your meter, measuring meter will interfere. Suppose you want to measure the length of your height by means of will interfere with you. How can you measure? Probe must be completely non-interfering with the things to be observed. But if you want to see, or suppose not only by naked eye, but suppose you microscopically you see, you have to bombard some photon, some light. How can you see? Light falls on it, get rebounded, enter. That is why, because these are the concept of micro world, the probe is interacting with the particle. When the probe is interacting with the particle, it is not possible. There will be some error in position momentum. We call, uncertainty principle, delta x, delta px is equal to h cos. So इसमें भी कुछ गलती रहेगा, इसमें भी कुछ गलती रहेगा. Product of the uncertainty is very small. If you want position accurately, you have to compromise with momentum. If you want momentum accurately, you have to. But classically, both can be measured. There is no way. इसका position measure कर सकते हैं, इसका momentum भी, if it is moving velocity, इसको momentum भी measure कर. But classically, quantum mechanically, there will be some error. Measure hobo. There will be some error in measurement of position as well as the measurement of movement. That is what is called Heisenberg well-known uncertainty principle. Let us. So photoelectric effect black body radiation is completely supporting that classical theory is not sufficient. We cannot say it cannot destroy. It cannot be sufficient. So you need for some other mechanics, and that was some other mechanics is the atom. Next, let us switch over. This we have already explained. All these are the parts. If you need to know, it will help. Next. Now you see light has a dual character. It is a wave character. I have already told particle character. Particle character which experiment conform particle character, Compton effect, and which experiment next previous. Which experiment support previous. Which experiment support the wave nature, interference, and diffraction. Now, when there is a dual, so that is it is called the wave particle duality. Wave particle duality. So now, if you say the same thing today at this moment wave, tomorrow you say, or the day after, not tomorrow, next moment if I say particle, do you not tell me that you are a madman? Sir, at about 10:20 you told that this is a wave. 10:21 you are telling that it is a particle. It is madman. So It is. That is, it is. Sometimes it is a wave and sometimes it is a particle. So what is the correlation, sir? Correlation is when the light travels from one point to other point, it travels as a wave. But when when he falls on exchange something, or when it falls on some material body, it gives as a packet. It becomes a particle. It shares energy as a packet. It moves as a wave. There is nothing wrong. Suppose you switch on a light, it falls on the wall. So from the point of light to wall, it moves as a wave. But at the wall, it gives energy to the wall as a particle, as a exchange, just like love flows, like a wave. But when it meets, it will give you an exchange. When it is a particle, on exchange, it will be a particle. On travel, it is a wave. So there is nothing wrong. Wave and particle dualism. Wave and particle dualism. You know, dualism is not a concept of science. It is a concept of human social science also. You know, same man is a devil and same man is a God. Same movement you are acting is a devil action. In other movement you are godly behavior. Just like, and there are many examples that mind and matter. Sometimes mind dominates and health and mind. Sometimes mind dominates health. Sometimes health dominates mind. So mind and health are also dual nature. If mind is restored, health is restored. If health is restored, mind is. So dualism is not a scientific quantity. It is also happens to be social. Same river. It helps by giving water to the public, of the people, and same water during flood, destruction. So during the first part, it is creative nature because it supplies water, irrigation, and also during flood, it destroys. A man who commits suicide, also one day before he may be a perfect man. But devil action some enters to his brain, so he commits suicide. So demon and devil, many things are dualism. One way we should not go to it, so that our so look, it is dualism. It is dualism we can. Because if you are keenly interested for quantum computation, don't think they are wasted. These are the only way you can understand what quantum computation is. I am still telling. Next. Next. So it, as you know, we can compromise between two. That is why light is called vehicle. Wave root WAV, because it is wave and particle. So wave and particle combination is vehicle. Just like now when a newborn baby are given half name from mother, half name from father. Previously, because male is dominated, the name goes to the father only. But now male say, why not I? So, आपका दो नाम, आपका फर्स्ट टू लेटर, last name, तो नाम दे रहे हैं. Similarly, wave, WAV, particle, ICL. So it is called the vehicle. It is not uncommon. Next. I have already told how it propagates like that. Next. We will see. We will see. Summary I told. We need summary. And you see, this is the constructive interference. Now, whenever there is an interference, it is constructive interference. That is the reason why I am just giving you a hint why it is necessary. Classical computer, because unless you give a tangential touch, you may be feeling these are boring. Classical computer rely on bit 0 and 1. You might be knowing more comfortable. Quantum computation rely on qubit. That means classical computer either 0 or 1. Either switch on or switch off. Either spin up, spin down. Either polarized or unpolarized. Either you can say ground state or excited state. Either yes or no. There is no other in between. But qubit, partly yes, partly no. Qubit जो हो जाएगा, it is called the quantum superposition. It is called the partly yes, partly no. C1 yes, C2 no. Whether yes is more or no is more, how can you know? C1 square. More square will tell you that it is probability of C1 is this, and probability of yes is this, probability of no is this. So if the probability of no happens to be 90%, probability of yes happens to be the 10%, then naturally yes is will be there. But you cannot say it cannot be no. You cannot say it can be no. That is the why. What is the difference between qubit and WIT? WIT is the unit of classical computation. 0, 1. All any problem you give to the computer, you might be knowing better than me. It will be converted into string of zeros and ones in a classical logic circuit with wire. Get it done. You have to write the algorithm. I think you are much smarter than me if you happens to be computer science. But thing is that your entire algorithm is written in the string of 0 and 1, 0 and 1. Yeah. Many type of 0 and 1. Yes, no, high voltage, you have got OR gate, AND gate, but you have electronics. So, and also it is called the NOT gate. What NOT gate will do? X code, it will make minus X. And your OR gate may be addition. And the truth table. 1, 0, 0. Yeah. All classical gate. These are all because there is no other alternative between 0 and 1. But when you come to the quantum mechanics, quantum bit, there is C1, A, C2, C1, 0, C2, 1. For that reason, I am explaining dual nature. Not that I know, I kill your time, I am explaining. Those things I am extracting, which will be necessary in future. Okay? That is why I am also giving hint where you need. Maybe today's class, maybe tomorrow's class, or whatever may be. These are necessary at certain level. That is why I am explaining. No. Yes. Yeah, X-ray is not so necessary. Please. Okay. So particle properties of the wave, photoelectric effect, Compton effect, experimental confirmation, and these are the wave particle duality. And wave particle duality is one root for your quantum nature. Now the question is that if the wave tends to be wave sometimes, particle sometimes, why not particle will also claim he particle sometimes, wave sometimes? Because the nature of symmetry. Try to understand. First part is light is a wave, you are preoccupied in your mind, but it can be particle. Similarly, electron is a particle which is preoccupied in your mind. Why not it can be a wave? Because nature law symmetry. So it is not only that wave can be treated as a particle. It is a manifestation, two manifestation of the same thing. So if there are two manifestation of wave, one is wave and other is particle. Similarly, there is also same two manifestation of particle, sometimes wave. Now when you talk about electron flowing, in the electron microscope, electron is not a particle. Electron is a wave. Electron is a wave. So it is also particle can be treated as also wave. The reverse is also true. Next. So the particle is a wave. What is its wavelength? Because when you say particle is particle, then you are satisfied with the position, momentum, and energy. When particle is a wave, you should need wavelength. And wavelength is related to momentum by de Broglie. You might be knowing de Broglie relation. De Broglie correlated between the particle parameter with the wave parameter, well known de Broglie. All of you must have come it, and you must have done also numerical. Front numerical. Without understanding also, you can do the numerical. So it is because. So now the question is, who decide whether it is a particle or a wave? It is lambda. If the lambda is more than a particular scale, it is a particle. If the lambda wavelength is less, then it is. So not only the electron is associated with a wave, similarly elephant is also associated with a wave. But why don't you perceive the elephant as a wave? Because wavelength is less. Why wavelength is less? Momentum is more. Momentum is what? So when the mass of the elephant is how many crore times larger than you can calculate than the mass of the electron, then wavelength will be accordingly smaller. So wavelength is smaller, much less than the desired scale. Always you think of elephant or forget about elephant, even a coin also. Always you think of a coin is a particle because wavelength is much less. Always you think of electron either a particle or a So it is not what perceive you, what really decide when, what it should be, what it should be. Odia, are you comfortable with Odia? Not always. It is not that I am telling Odia, not that at the cost of English, just to repeat sometimes. Because और हिंदी में तो समझ सकते हैं. ओके, तो अभी जो भी आप सोच रहे हैं वो नहीं, जो सोचने हैं जो रियल है, थिंग्स आर डिफरेंट, थिंग्स आर डिफरेंट. नेक्स्ट, या our traditional concept of particle localized, definite position, definite momentum, that we तो मैं those बार बोला कर. Skip. Our traditional understanding of wave, how do you access it next? How do you associate wave nature of particle? What could represent both wave and particle finding? Yeah. Anyway, wave packet. Now the question is that when you treat a particle as a wave, it is particle, there is what is called the wave packet. So that you might be knowing phase velocity and group velocity, very well acquainted with +2. So particle, suppose an electron is flowing, it is not associated with a single wave. It is associated with many waves. All the many waves, they form a packet. That is why the light travels in the form of a wave packet. Inside the wave packet, particle is there. Inside the wave packet, so wave packet is the practical representative of the particle, and its velocity you call it as a group velocity or particle velocity. And light as a wave, the velocity you call it as a phase velocity. That is the reason why it is, now you come to the answer, why it is very difficult to know the exact position of the particle, because particle is inside the wave packet. Particle is inside the wave packet. You don't know where the particle is. You don't know where is the particle is. So uncertainty will be equal to the length of the wave packet. So within this length, it may be there. Within this length, that is where the particle exactly is, you cannot determine classically, because it is within the wave packet. It is within the, but wave packet is not. It is of understanding, very small. So particle is there. This is also not necessary. Okay. Now you see, taking that concept, I have given a verse or a poetic expression. This of expressing everything in a poetic form. I have composed a poem, and this is the poem. I don't want to recite. You see, classical. Now you see, you understand everything. Now, if I could have written the poem at the beginning of the classes, I fully understand. You can't understand anything. Now with this, if you understand the poem, you will understand my talk. This is the test. If I give you a poem and tell you write an summary. If you could write, that means you understand it. What I taught it. You know, classical to quantum is not step transition. Conventional doctrine to imagination. Classical is conventional and it is an imagination. Our macro world that we see is a classical. Quantum is the description of macro. But it is written in a poetic form. Naturally, non-conventional way of teaching science is better than conventional way. That is why the government is encouraging, tell the story, tell the poem. Conventionally, if you teach, people will be fed up and they cannot learn. Only interested for the numerical so that get exam hoga, JEE exam hoga. They don't know what is uncertainty. They want delta x dic, delta p dic, on the delta v and momentum, velocity, and everything. So now you see, classically is full of second law and order. Newton's law. I told quantum description is a probabilistic nature. Is there any doubt in understanding? Now I read it. I think it is very essential. Classical CM means classical mechanics, not chief minister. CM can measure both absolute accuracy. Quantum mechanics is uncertainty and indeterminacy. Classical probe don't, in classical mechanics, probe do not interact with object. Look, in classical mechanics, probe, suppose you want to measure the length of a slide. Have you done it close to experiment? Slide caliper is a probe. Is it interacting with the button? No. If it interact with the particle, the length will not be length will not come. But if you want to see a light intercepts the electron, because the electron mass is very less. You know, in classical mechanics, probe do not interact with the object. Probe object interaction is a quantum thought. Body to be observed and body observed. Body to be measured and measured. There are two things. Here you see that matter to be observed is one bit. Things to be observed is also another bit. जो क्यूबिट का कंसेप्ट आएगा क्वांटम बिट से क्लासिकल बिट से क्यूबिट 0 1 1 0. Suppose you want to measure the particle whether it is a ground state or excited state, you need some microscope. Some meter is necessary. That meter interact. That meter interact. So that meter scale is also another qubit, and body to be observed is also another qubit. And they are in constant supervision. They are in constant supervision. What is called? Quantum superposition. Sorry, quantum superposition. And you see, quantum object is dual, wave and particle. Dual nature of radiation is equally possible. Unpredictable wave path, lag determination. Uncertainty in finding position and both you cannot tell. Particle location is constructive, destructive is elsewhere. Okay, quantum theory has the fuzziness, unlike classical. Then quantum mechanics is a fuzzy. Classical is certain. Classical is certain. The dual nature of radiation, wave and particle. Uncertainty, indeterminacy, duality. Anyway, I can send you the poem. You can read at your own leisure, so that if you understand the poem, you understand that up to this slide, it will be preview. It is a test. Next. Now, you see, if it is a wave, suppose you take light is a wave. So, whenever there is a wave, there is some wave. Wave word comes from, there is some variation. Suppose it is a sound wave. What is the variation? Pressure variation. Suppose it is a light wave. What is the variation? Particle variation. If it is a water wave, what is the variation? Height of the water level. Whenever a wave is traveling, there is some variation. Sound wave, pressure fluctuation, compression. When the water wave, when you just drop a stone in the water, a wave is created. What vary? Height of the light particle. If you give a very small light object, the light object will also small pieces of the paper. They will also make up and down. So similarly, if you say the particle is a wave, what should vary? Probability amplitude will vary. Here variation is probability amplitude. If I say this particle is C1A plus C2B, C1 is the probability. So at this position, probability is 70%. At other position, probability is 80%. At this position, probability is 90%. So variation in wave nature is, because quantum mechanics is the wave nature. So variation is probability will vary at the, suppose this is a very common example also. Right now, suppose your friend will go to your father and ask me, where is your daughter or where is your son? Your immediate friend go there and ask your father, can you tell me where is your daughter or where is your son? Now, if it is a college hour, he will certainly tell he is in the college. The college in the computer science department, MTech level or whatever. Certainly. But there is a chance also you fled away, not attend the class. But certainty 90% he will come. But in the evening, if you ask, where is your son? What will tell? Sir, class is off. He may be in the playground. If your son happens to be a football lover, he may be in the playing. Your father will tell in a probabilistic manner. Because you don't know where is he. He may be in the library. He may be in the what? Ground. Depending on your hobby. Depending on your hobby, the father will tell. But all the 4 to 5 places, if your friends are very in the need of your son or some confidential work, where I meet, sir, this is the right time that he may be in the playground. He's a cricket lover, he don't go all other games, you go to the cricket, he may be there. That is, the father feels that probability of finding the correct match is higher. But that doesn't mean that they will catch you in the cricket. By the time you may be also in your hybrid. By the time you may be your other friend. So, because the time is odd hour, odd I can't say, the time is where your confirmation is less, then he will tell you in probabilistic manner. Similarly, the amplitude is the probability. Amplitude of finding here. So, amplitude of the wave is the vary. Next. And similarly, just like your sound wave is the equation, similarly, your quantum mechanical wave, de Broglie wave, important de Broglie is given the relation lambda is h by t, you call it a de Broglie wave. So that is also called the wave function. So psi is the quantum mechanical wave. It is deciding how it changes with respect to according to the equation, what we know in your part. This is what is called the Lagrange. If you are if it is not so, suppose your quantum mechanics understanding is, I am telling both online and offline students. If your understanding of quantum mechanics is close to level, if you want to do research in quantum computation or something, you apply yourself at least +3 quantum mechanics. +3 university ka quantum mechanics kitab lekar padna. And only you can understand what is quantum computation, how it theoretically, modeling, project, is clear. If you are a +3, then there is no problem. MSc quantum mechanics. But on an average, one should have a +3 level quantum mechanics paper prescribed by quantum mechanics universities up to any university, +3 level. So this will help you to excite, to understand something. Otherwise, mechanically you can, in which way you can do, I don't know. But conceptually it will not be clear. And you see, wave function describing a particle. Wave function is a parameter which gives everything about the particle, just like it is an identity part of the particle. Suppose it is the electron, this electron is associated with the wave function, and the wave function tells you everything about it. Just like identity card, my name, my class, my code group, everything. So similarly, position, momentum, everything. But it is not written. Oh, my electron number 2, your position is this, your momentum is this. You have to find out. You have to find out. For finding out, you need to operate. You need to operate. For each physical observable position, momentum, there is a operator. If you operate it, you will get the eigenvalue equation. From that, you can find what is the position, what is it. There is it is not that next. So psi is an imaginary. You know, wave function contains all information, but psi is not real. Psi is of the form A plus psi b. Imaginary means A plus psi b. What creates meaning is psi star psi. You know, if psi is A plus psi b, psi star is A minus psi b, psi star is equal to real. So it is the psi star, that is psi mod square. So that is plus 2 elementary physics. Psi mod square will tell you the probability of finding the particle at a particular point. Suppose I want to know what is the probability of finding an particle in a distance dA. What I do? Psi mod square dA. Suppose I want to find a particle in an area dA. What is psi mod square dA? Suppose I want to find the particle in a volume dV. Psi mod square dV. Suppose a quantum snake. Forget. Suppose the snake enters in a pile of stone. The pile of stone, one snake. That snake is a quantum. Now, what is the probability of finding the snake inside the pile of stone? Psi mod square, volume of the pile. Volume of the. Okay. And is the probability always the same? Suppose, you know, this is the best example, you can understand why the probability varies. Suppose forget about that quantum classical, just like poison is enter in a pipe, you psi. But is there that probability of finding this snake is same everywhere? No. You could have easily killed it. So what you do? You have to. What you do? You have to hold this phone. You have to alter this phone. So you see, sooner you alter this phone, suppose the pile consisting of 100 phone, you will, if you just turn 98 stop, you will not get the what? Snake. Because snake always tries to go from dangerous region to the safer region. So you may get the snake while turning the 100 stone. That is why leave no stone unaltered. There is a, socially we can say, हर चीज को कोशिश करो. Leave no stone unanswered. That means when the stone is destroyed, he also threatened. He also threatened that my life is gone because already I am part of the people with bar and other things. So when you disturb it, it will go to the other place. So gradually its position amplitude changes. First time it may be at the middle of that. When he has the disturbance, he will go to the left. Similarly, same thing. It is a classical or quantum. Out of here, it will enter into the safe zone. The safe zone may be the 100. Safe zone may be. So if you try for 99 zone and return, I inhale, then you are over 99%. And inhale, you have to do the last one. The snake may be the last one. The probability of finding the snake varies just like baby nature. Just like baby nature. Similarly, quantum particle, it is a snake, it is. But basically, the same thing doesn't happen. If there is 100 students collected and if you distribute Lodu, what they will do? They will come forward. They will come because Lodu may be existed. So they will come forward because we have a common. But electron has no common. So their probability will definitely vary. Suppose something is distributed. Will you go last day or will you come first day? Kids, they will always tempted to come with first day and actually what you do then. So it is like that. So probability varies. The purpose of telling is that probability varies along the area, length, what? Length. So difficult to understand. Once difficult, you can conquer the quantum computing. You can conquer the quantum computing. So I have already told why there is we cannot measure position and momentum accurately. Sometimes when I say we cannot measure position, momentum accurately, what concept comes to your mind? I may not be a good experimenter. There cannot be any instrument available to measure. I can't measure accurately both. What your father will think of? Yeah, you might not be a good experimenter. What your father will think? That your instrument is not equipped with a good instrument that you are on, but not. Even though you are a good experimenter, even though all instrument is available, it is because of probe is interacting with the particle. Why you can't measure? Because probe is interacting with the particle. Light is interacting with the electron. That is why it distorts the position. And if you want to measure the position accurately, momentum gets distorted. If you want to measure momentum accurately, position gets. It is not that you are not that your institute is not equipped. It is the law of nature. It is the law of nature. All quantum particles, everything you can talk in the language of probability. Everything you talk in the language of next. Oh, sorry. Next. You are disturbed. Don't worry. Sometimes I. No. Actually, sometimes I don't. I'm not ordering you. Just. Next. Oh. Similarly, energy time also. There is another uncertainty. Energy time means suppose there are quantum level, ground state, excited state. Energy, what is the energy of the particle in that particular state, and what is the time it is staying in that. Remember, when it is excited state and ground state, you know what is the transition rate? When a particle is excited from ground state to excited state, do you mean it will stay for one day comfortably to take leisure? Can you know? Do you have an idea? The lifetime of a quantum particle, not all particles, electron, proton, is less than 10 to the power minus 8 seconds. So don't think that when you feed energy, the electron will go to from ground state to excited state. He can take bed rest for one day and again come. Just like we are climbing the mountain and in what do you say, picnic. Stay there, prepare your food, take rest under the umbrella, under the tree, and come in the afternoon with totally. It will come within the less than 10 to the power minus 8 seconds. So there is no instrument available to measure how much time it takes. By the time you fix up your meter, measuring clock, to know how much time it takes, it's not. It's just like electric motor. It's just like, and suppose you want to measure energy also. By the time you fix, that is why probe is interacting with the measuring instrument. So how can you measure? Everything you can say there is delta is the error. Delta is the error in measurement of energy. Delta T is the error in measurement time state. That product. So in order if you want to measure energy activity, compromise with the time. If you want to measure position activity, you compromise with the movement. There is no other way. And most of the time also, in your social life, are you not compromising? If you want good, handsome lady to marry, to compromise with the qualification. And if you want that your wife to be equally partner, you have to compromise with the other things. So down. So sometimes compromise is not a law of quantum nature. Compromise everything quantum. Everything you want. Highly salary, groom or bride, with good status, with good look, smartness, don't get it. You have to compromise with something, right? That is of nature. You know, science mimics society. Science is not different from the society. Most of the laws of science mimicking society. Next. Next. Next slide. So well-known equation is this. What is it? I am not going to create well-known equation. Wave equation. You know, Simon wave probability. Next. You know, paper science is meaningless, but more Simon wave is a real. S1 plus picture. Next. And well, this next. And this is Schrodinger time dependent. No, how psi develop? Schrodinger equation means how psi develop with the time. How wave function and an electron is associated with wave function. What is the change of the wave function with respect to time is Schrodinger. You need not worry. That it is, yeah. You see, yes, another product. You see, this is called the superposition. You know, qubit superimpose. Superposition, entanglement, parallelism, decoherence is the everyday occurring term. If you go to the domain of quantum computing, yes, that's a term. Frequently occurring quantum superposition, quantum entanglement, quantum parallelism, quantum what do you say, decoherence. These four terms to understand clearly, these are the and are necessary to understand these four terms. And these four terms are ABCD of the quantum. Sorry, quantum not mechanics, quantum computation. To understand, have an idea about the nomenclature, what we say, language of quantum computation, quantum mechanics, whatever necessary, I will tell you. Okay. Next. You see, this is the superposition. You see it, you will very interesting. Just try. So you see, suppose there are down slit axes. There are two slits. Look. Now suppose you close one slit and light is coming. Electron wave or quantum wave, whatever. So when you close one slit, suppose slit 2 is closed. So finding the electron will be what? Probability is more here. Kind of. Because side when slit 2 close, slit 1 open, then we will get first one. Okay. When slit 1 close, slit 2 open, you will get the second one. So when you open both the slits, what do you expect? Third one. But it is actually not third one, it's fourth one. Two. When slit 1 open, first one. This is all. Because the slit 1 open, slit 2 close. So electron will come here and probability of finding here will be there. Suppose there are two doors. If you close that door, then you will find. Well, this is no evidence of that. So it is evidence. When both doors open, I should find the probability of this and this, but you are getting this. So wave function add. I will add, but probability not add. Probability add and what is that? P is psi is equal to psi on cosine. But P is not equal to P1 cosine. P is equal to P1 cosine to us. Other term is because of principle. Other term comes because of quantum. You just give me 10 minutes time. I superposition थोड़ी देर के लिए मालूम है. It is one. So probability is not because of it. So you are getting very nice. Okay. This is not so necessary. Next. A function contains all information, but it is not written like an identity card. My name is Professor Pandey, my roll number is this, my blood group is this, not that. But you have to find out. Everything is hidden there. Everything is hidden there. How do you find out? Suppose I want to know the energy of me, I have to operate me with energy of me. If I want to know the position of my, if I want to know the spin, another parameter of quantum particles which has no classical analogous. Remember, there are some quantum particles that are classical counterpart 9. Spin is a spin up and spin down. Each quantum particle has a spin up and spin down. It has no classical analogous. So you have to operate it. Yeah. Yeah, you see, particle in a box. Now you will see here what is a quantum. And it is a classical particle. Suppose you have a classical particle inside a box or inside a almirah, you say, of infinite. Remember, there are two things. Almirah of finite height, almirah of infinite. If the almirah is of infinite height, he kept your value. So the probability of you said you can something and your wife is happy. But there is a reason I have kept in hand. Will your wife will go to a particular cell for a particular point and get it? Or he will do. He will set all this up. So it is just a suppose it is a very auspicious ring given to be married. We don't want to. So he eagerly said what? All the cell and all the corners of the cell. Yeah. Yeah. But it is a quantum field gifted by your force. And the probability of finding the ring is not staying there. This is what is called beautiful law of particle. Next slide. You see, if she searches probability, if she searches the first cell, he should first go to the mail. He should first address the hand to the organ. And if it happens to the second cell, here the probability is high. But the same middle probability is 0. When it goes to the second cell, the probability of finding the STC is 0 at the middle. It is higher there. This side, and when you go to the third one, you know, every cell, every point, every cell is not equal. But every one of the cells is not. So probability, that is why it is very. That is why anything very, facts vary. It is very volatile. You are very facts. I think tomato is 10 rupees. After 3 months, tomato is 40. It is not very. Tolerance will be not only use Quantum computation in market, finance, mutual fund. It has no era where it can tell me where it will not be used. Instead of enlisting where quantum computation will use whether medicine, weather forecasting, sensor, market, social science, finance, where it will be. That is why there is a quantum jump understanding this. So take pain in understanding this quantum. So you see the probability that. So essentially, what's the particle and wave summary? Particle and waves vice versa. Quantum states are discrete. Quantum states are. Example, there are cells. If there is no cell, if there is no cell, open wall, then everywhere will be same. Everywhere will be. Suppose a small baby, there is an accident, small baby hauled out in a tube, in a recently one. So is there any chance that it will be here? Here. Chance will be everywhere. Chance will be everywhere. But here it is discrete. Here it is not continue. Continuity is the signature of classical physics. Discreteness is the signature of quantum. Remember these two. Discrete. Well-defined skill. Remember, each quantum particle are ready in the knob or in ready speed. Measurement and well-defined. Measurement determines the reality. You see, when you measure it, before measurement, you will understand probably. But when you measure it, suppose say example, suppose you go to the winning time and tell when it was your father will tell in probabilistic way. Your friend will eagerly set up you, and if he finds you in the cricket ball, whatever. You are so long as you don't know where is your son, where is your friend, you got information from your father, his father. These are the probable places, and you are desperately searching because you are badly need of the friend at that time, and you find first you go to that place where your father told the probability is high, and suppose you got it, then the function comes. That is what is called the decoherence, and that is the negative part of the peacefulness of the. It is so with how to minimize the decoherence, because once it is measured, it will become sequential. So it is there. Partly yes, partly no. Either yes or no. There is a well-known experiment. I will tell you even a 10 minutes. These things also written in the form of actually Professor teacher Tom written form. Actually, I had a habit of writing form subject other than physics, but long 5 to 10 years I am writing subject related to physics. But unfortunately, I forget to give the composition. I will send it. And what you find is that my profession and passion meet together. Because I am doing justice writing poem in physics. So my profession is in physics and my passion is writing poem in physics. So that meet together and this is making a happening. So anyway, I will give you. Next. You see quantum. It's not quantum term. I am also not versatile with all the terms. Quantum superposition, quantum entanglement, quantum cryptography, quantum teleportation, quantum gate, quantum Brownian motion, quantum cloning, quantum Gino effect, quantum noise, quantum dense coding, quantum correlator. Okay, you are more experts which are very in quantum computing part. They can, but I can partly tell you. Quantum what? Quantum walk is coming under Brownian motion. Random walk. You see, Sarah given that a trumpet walk. Right? Brownian motion, when pollen grain, Robert Brown, what else? When pollen grain is suspended in the particle, they make erratic motion. Do you know it or not? Don't take it. When the pollen grain are suspended in water, the pollen grain made erratic motion. You know, when the science was not developed, what is motion?
The notion was because the pollen grain is biologically living organ, and living organ, they are erratic motion because the pollen grains are living. People were thought like that. Then it was also found with the core particle, dispersal particle, non-living. Then non-living तो ऐसे होते हैं. Ultimately, they found the Brahmin motion is due to not because of their life or because of their will and pleasure. The water molecule hits it, picks it. It is the collision between the water molecule with the lighter particle. That's like in a football team, your football is dancing in the football court is not because football has a life. It is because how you kick it. Your kick decides in which direction football will go. But people were ignorant. People don't know that water molecule is coming to this. This is the problem. Forget. Now comes to the random one. Now suppose a normal man with sense, I will walk from my guest house to this. What you expect? The velocity is this distance nearly is even in the car. So suppose a old man velocity is this, distance between the guest house is this. So what time Dr. Panigi will be here? You will divide distance by velocity. You will get time. It will get time. Suppose a drunkard will walk. What do you do? Drunkard walk just like Brownian walk. First step this, second step this, third step this, fourth step this. Because it gives no sense. Are looking for probabilistic. How much? So suppose I have to overdrunk in the guest house. Then you cannot predict when I will reach. It may take 1 hour, I may be saying at the gate. Because I have no sense. I am fully intoxicated. So because of that drunkard walk is a random walk. It is a probability. It is a probability. In 3 steps, you may go 1 step, 4 steps, you may come this side, 5 steps, you may come this side. That is called the random walk. This comes under this. And all the volatility of the market. You have invested money in the mutual fund. Today, you know my fund increases this. Tomorrow, you know my it is decreasing. Day after tomorrow, that can be also because of the quantum Brownian. I think not a theory can be done. I'm just giving you a problem. I'm not giving you a solution. I'm giving you how much problem, how much you extend. Suppose you are an electronic student. You go quantum gate. Suppose your mathematical modeling is good, mathematics. They will go Brownian motion. Why they will go quantum gate? The research topic, if you are really computing, you can go the whole way. So it is subject to one thing. That's very multi. Only 5 minutes I will take. Next is quantum. This is you see National Quantum Mission. Since I am not talking to attract you towards my quantum computation classes. I am talking total cost 6,000 crore to be invested within 5 years. So if you write a project blindly, utterly quantum, this we can know the computation. If you venture in the quantum world, this time, after 10 days, after 10 years, it's settled away. If all will become intelligent, then nobody will be good. Now it is the time that you reach the opportunity. It is time to reach the opportunity. Till the moment, that's all. So, what are the things you can do? You see, single photon, communication, entanglement, superposition, many things are there. There is a lot. So, when the nanotechnology came to the field, I have experience. Research life, people milk the name. Now go the key job. When superconductivity comes, during my NSC, any project written in superconductivity, get it. Similarly, when nanotechnology comes, if you write 10 to the power -9, you can't put to write that. If you write nano, nano is 10 to the minus 9. But if you utter the word nano, or Einstein को nano कर देंगे. If you are writing Einstein, if you write in terms of 10 to the 8 into 9, then the what? It the thesis glamour, the project glamour. This is what one. Similarly, now this era of quantum. Write any sorts of project, likelihood to get. I would say, sir, quantum NIT talk. I will but the data talk दिया है ना अर्थ आता है उसके पढ़ देंगे ना next if you allow because that's what is the so I'm very happy that easy I think it is an opportunity not as a burden.
So, thank you, sir, for your nice talk. I had a second session with Professor P from Hyderabad, as I said already. So, I request you all, after, can we start from 2? So, I request you all, please come and join from 2 p.m.
And now oh it is too it is very late to pass. So who are okay, I am ready.
See, actually, this is all for you, okay? And you are getting the opportunity to learn this new technology. Even, see, this course we have started in our department, but our plan is to like explore this field as a research field. Yeah.
And he belongs to the same Mandara University, but he develops a lot. So,
Yes.
mathematician class in our
He has been teaching this last 23 years. Okay. So everybody must come at by 2:30. Okay. Don't make it delay. And online participants, you are also requested to join at 2:30 after the lunch. Okay. So thank you. If you are online participants, you just call me or you can drop me a message on my WhatsApp number that is given already. So thank you. Okay.
Okay.
डिपार्टमेंट बचपन से एक शौक था
अच्छा अच्छा जो
नहीं physics but my father didn't personally I'm an IT student but I'm very much interested in physics
IT में जो भी तो information technology और
computer science and engineering
that is cryptography. I will tell you briefly.
नहीं ये सारा चीज at the same time लोग का गेट के एकदम आधा रिपोर्ट
But in the joint course, unique course I have not denied. So many website but वो भंडार very clear about this is quantum mechanics.
my physics में interest quantum mechanics तो it's a branch इसका हमको पढ़ चुका हूँ Einstein versus Bohr हुआ है पढ़ चुका हूँ quantum physics 1 year का चले
When I do for
ये बहुत इम्पोर्टेंट चीज है, जब आप सीख रहे हो ना, ये एक्चुअली